Hello everyone, again welcome to the Linux networking class. This is uh, the the topic is actually the Linux programming languages. As you know, today we are still going to continue the Linux networking. Today is lecture 5. We will be talking about the DNS where we left off last time. Let me just do a small recap. We talked about the DNS or the domain name system. We talked about the point-to-point protocol, and then essentially, the remaining the major recap we will do it a little later because we have one more topic to cover in this section. So I just want to leave you with just that. So we know that the domain name system is used to map the domain names into their IP addresses, and we know the IP address is formed out of this 4 octets. 3 of them denotes the network to which the host belongs to, and the last one itself is the host number in the network, or how to identify the host inside the network. And then we know that actually there is the subnet mask, which we can use it to separate the network address from the host. And host is typically not the last octet, but it's also like either it may be a subset of that octet, or even it can encroach into the 3rd octet also. And then we also saw basically how the point-to-point protocol works through the gateway. Basically, like whenever there is a message that needs to be transmitted, essentially, if it is within the network, it communicates directly to that host and basically exchange the message. If it wants to go outside the network, then it goes through a gateway, and then the default gateways are all known, and there are the directories are actually stored in various computers that we saw, and then how they interact. We will come to that one a little bit later, and we will formally take you through that section. Any activity for today? Actually, I'm not assigning any activity for this lecture. Again, we will complete the email aspect as to, because 2 applications of the domain name system itself is one is the web systems, and then the other one is the email. We also briefly saw, like in the I think the 3rd lecture, how a web server works, or how a client server architecture works, where we open port and basically communicate into the server and basically exchange messages back and forth using the same IP protocol, or the OSI protocol that we talked about and we learned earlier. So let me now talk about the remaining section for this topic. Before I go there, I also wanted to give you a brief look into the domain name registration itself. The domain name registration for the worldwide domains is controlled by this corporation, or the Internet Corporation for Assigned Names and Numbers. We refer it to as ICANN. ICANN publishes a complete list of the top level domain registries and domain name registrars. There is another one called DNIC, DNIC, which is the Germany NIC that holds all the Germany based data. And then similarly, there are other network centers, essentially, like which also hold the top level domain data for various countries and these big corporations. And then there is also this company called VeriSign, which used to actually, or even now, with controls the .com and the .net domain names. So anytime if you want to buy a .com domain name, you need to approach VeriSign and buy it. Actually, they do charge money. There are several companies which give you domain names today, like Google and several other companies. For a charge, basically ranges from like $10 to $50–$60, and you can also like apply directly to ICANN and actually register a domain name for a fee. They also charge a fee for that. these kind of the top level domains essentially, like then you can actually spawn multiple domains, and the Googles of the world actually can distribute domain names because they have actually sublet or subcontractor. They are the subcontractors for some domain names, so that you can buy it from them directly. So and then they also probably charge some maintenance, and they do some value added services like setting up a web page for you, and then essentially like, populating with some additional data, things like that. So I think it is a profitable business proposition for everyone. So I just want to keep this in mind when we go through all these things, that it's all like this commercially motivated. A lot of these things are there. So let's look at email. So the email actually is transferred on the internet using this SMTP, very widely known. This is a simple mail transport protocol. Email itself is divided into three categories: the mail transfer agent, which is actually moving the mail from messages from one server to another; mail delivery, which places the mail into the mailbox; and then the mail user agent displays and manages the email messages for a user. This gives kind of an overview of how things do work. As you know, like the configuration of mail is fairly easy nowadays. You need to know who is the mail server essentially. So you need to register that server into your machine, and then you need to identify yourself as an address. So once the address is known and the mail server is known, then you'll be able to send the emails out, which basically goes to server, and then from server the server distributes to the internet, the whole internet. And so we will go through these things in detail. So the user accounts have associated mail accounts. So every user has related mail, and the email is placed in this this particular directory, that is /var/spool/mail. Again, go back to your lecture 1 and lecture 2 from the Linux system, where we mentioned that actually everything is represented as files and folders inside Linux, and then this mail delivery mail is also kept in a file under this directory. And then the mail is retrieved using these one of these ways. One is the post office protocol, or POP3, which used to be like very popular until recently. This POP3 essentially, like its server is it downloads messages to the computer, and then nowadays the more prevalent one is the IMAP or IMAP, which is the Internet Mail Access Protocol. The IMAP servers are, again, they just form into like two different classes of servers. Nowadays the more prevalent one is the IMAP servers. And then finally, like your web browser itself can act as a mail client. That's very popular when you talk about like Yahoo Mail or Gmail. In fact, behind the Gmail, actually the IMAP server is also there. Same thing for Yahoo. Yahoo and Gmail both provide like IMAP servers, and then those servers deliver the mail directly to your web browser's mail client. So now let's talk about the POC mail, which is like a email filter. So the previous one, like we talked about this all these various IMAPs and POP3s. They are like they come under the mail user agent essentially, like that we studied here. Now we'll talk about the mail delivery agent, which is the POC mail. So the POC mail is a special delivery agent that acts as a filter and processes the email. based on some user defined criteria. It's difficult to configure, but sometimes if you are receiving a lot of messages and also you want to save them like in a very ordered fashion, then procmail the configuration may be worth it. Procmail is installed by default. You can think of procmail in the form of automatic filing. So you have many folders that contain mails, and then you can automatically file them into various things. Which one that you want to look at first, prioritizing, and also like some mails like can directly go into junk mail, things like that. So you can set up the rules and recipes and formulas for that. The procmail itself checks for a system-wide configuration file, which is stored in /etc/procmail_rc, and then it goes into your home directory to look for a .procmail_rc file. So there are some the configuration is done in two ways. So there is a global configuration that resides in the /etc/procmail_rc. That file you can override that with the .procmail_rc directory. So again, this file will have the recipes and formulas and all those what you want to take action on for a given message. So so now let's look at the reader itself. This is again the user agent, you can think of it. It's a text mode email reader. I think like you are all like familiar with the familiar with the various other email clients, Outlook or Yahoo Mail or Gmail. This looks like slightly primitive, but here it's basically like, I mean, this is the way that even various programs can communicate to you. So here the program is actually sending you messages relating to the jobs and also like some of the logs what is going on. We will learn about how to send mail to yourself and in a programmatic way, things like that when we talk about the programs themselves like Perl and things like that. There it's easy to actually put some mail programs. Here you can see that basically like it comes to the first mail and it waits for the command. So here the command is pretty much like a Unix VI based command. J is moving down, K is moving up, and then you can also like delete mail and undelete mail. Delete is D and undelete is U, and then if you want to mail a message, you just type an M, and then if you want to reply to this mail, then you just type R, and or if you want to forward the mail to another user, then you press F. Q will quit, and again you can think of this as another command interpreter where it basically like presents all the data and then it waits for your command here. So based on the command that you type in, it performs the next action. So that's a very easy to understand email reader and some writer. So slightly more complicated, like I mean, so here is one setup using the Netscape communicator. This is like somewhat old thing. So here again, it's a POP server basically, like I mean, then you can just add it. And this is an incoming is POP and outgoing is an SMTP server. So here you set up all those things basically, and then the where you want to keep the mail, that's the root. This is Netscape mail, so that you keep it there, and then you can actually like I mean this is the mail server setup. So and then you can add multiple incoming POP servers. So if you have like if you want to consolidate accounts from multiple sources, then you can just add all those different POP servers inside this. And then you can also the outgoing server is typically only one, and then here the local host is the outgoing server. And then there are other options here, like secure socket layer, which is all like much more secured communication. So essentially, like you can set it up as whether you want to use it all the time or never use it, or wherever it's available, then use it kind of settings. So pretty much this is what you will use to set up the mail. It's kind of it's a little bit old, this particular setup, because Netscape Communicator is something that we seldom use nowadays, either like Google Chrome or in Linux, the most common one. Actually, yeah. So that's pretty much concludes the. Actually, yeah, what I was going to say was the Firefox browser is much more common in Linux. Firefox also allows all these different configurations. So now let's we come to the end of this lecture. So we started our lecture with the domain name service itself. We looked at the resolver basically, which is essentially the client portion of the domain name service, and the resolver is nothing but it has the domain name plus the IP address. So the fully qualified domain name, the FQDN, consists of the host name plus the domain name of the host. That is basically like so it's all there essentially. So a typical example will be what we saw was IBM mydivision.com, which is fully qualified domain name. And then the point-to-point protocol that we saw was a popular method for making network connections via modems, and point-to-point protocol is provided by the password authentication, which is PAP, and the challenge handshake authentication protocols. Password authentication is a very simple thing. Essentially, just ask for a password and then basically you provide the password every time. The challenge handshake is more more involved, and that's why it's more secure. That's basically it's like an RSA token. Basically, there are random number generators which are synced random number generators, and then essentially you're generating that random number, and on the server side also it is generating something, and then basically you're asked to provide that. So you challenge the server with that, or essentially like you put your magic pin into this to generate a random number, and that pin, when it is sent to the server also generates a random number, and then you compare those two responses, and if the responses match, that's when you can authenticate the machine, and then that's where like the communication will start. We also saw the WB dial utility that to configure and manage the TCP connection from the command line. The dial D program, this automates the use of dial-up connection via PPP, automatically connecting and disconnecting based on traffic. So again, these are all something that we learned about, and essentially like to make sure that how to make those connections and see how the connections really impact on how the connections can be utilized for the communication. Then we also looked at the dynamic host configuration protocol, or the DHCP, where the clients can configure IP networking automatically by receiving the network address information from the DHCP server. So this I will say is one of the reasons why internet became so prevalent. Because if you look at the IP space itself, you know that actually the IP addresses are the octets, right? The 4 octets. So we have inherently some limitation between like 2 power 24 servers all over the world that are possible, and because those are the unique addresses that can be generated with 24 bits or the first 3 octets of the IP addressing itself. But today we can actually put together multitudes of addresses, and also we can communicate between these multitudes of addresses much more than this 2 power 24 with like very easily and without any loss of communication packets or collision of addresses or address collision. The reason why we can do this is because of this dynamic host configuration protocol, which means that when you go into a subnet that we know about, you know the term subnet now, we learned about this. So when you go into subnet, the different subnets can have the same address and they can still communicate between each other without any collision because of the DHCP server, which can resolve these collisions and resolve the addresses and route them appropriately. So a simple application will be like if you are say if you are leasing a internet connection from either your cable company or any of one of the providers, ISPs basically. Again, ISP has a subnet, and the ISP subnet is sending you an address. But tomorrow there is one more person who got added to the network, or the ISP itself actually has some new customers to serve. So there is inherently, like I mean, the ISP can run out of the address space whatever they are using. So instead, what they can do is they can start another subnet. So the subnets will be different; they will have different addresses, but they internally will have the DHCP servers, and the server will now assign addresses to the various hosts in a dynamic fashion. So that means that you guys can have the same address, but there is a DHCP server in the gateway which resolves these addresses and make sure that you are communicated and receives the communication appropriately. The benefit of this is now the ISP initially can sell only like so many addresses, or they can serve only so many clients. But now with having subnets after subnet, they can serve maybe 10 times more clients than what they originally had with the number of IP addresses. And for you also, it is a seamless process because the DHCP server automatically sends what the address and what it wants the client to be configured as. So you only know like about what address that you're sending the things to, and it automatically figures out whom to send, how to send, and all of this. So most versions of Linux include a DHCP D server and at least one of the 3 common DHCP clients. The lightweight directory access protocol, or the LDAP, that provides the directory services that lets users query a worldwide database for information on resources. So again, we know about the directories essentially. The LDAP is essentially like, I mean, it keeps only like so much information about the neighboring gateways or neighboring hosts, and then essentially like, I mean, whenever it needs the additional information, it gets it from those sources, and the message is also passed to those the main server then communicates. So this again made the whole communication process much easier. So one of the LDAP servers that's provided with the Linux distribution is the Open LDAP, and then the XTerm itself can execute graphical programs remotely by referring to a display variable. Usually, like we give like a dash display command in the command line option. We can also open up a port with the host name, which corresponds to a display, and then we can display various graphical items into that port. So we can use like a remote terminal. We can steal the remote terminal and display it in our terminal. Things like that are possible today. And this XDMCP, this lets users on remote X servers obtain the graphical login screen and begin using the X clients on Linux without first logging into Linux via Telnet. And then there is this remote utility R, starts with R, that provide a convenient way to execute commands. So to copy files we use RCP, and to open a remote shell, I think you all know the command. It's RSH, which is like, again, once you open the remote shell, then you can actually work on that machine. RCP is or RCopy is a remote copy to copy things between two servers that are in the network, or essentially like connected in a network, and want to copy between each other. Then we also saw about the UUCP protocol, or the Unix to Unix copy protocol. This is designed to facilitate inexpensive transfers. It's mostly like the email messages between the servers, and this was again it was used before internet connectivity was widespread. They are slightly different from the FTP protocol that we saw earlier. FTP also like achieves the similar kind of thing. One is this one is UACP is mostly machines that are connected in the same network, whereas FTP can go between networks as well. So, and then the web browsers, many of them are available for Linux. We already saw that. The popular being the Mozilla Firefox and the Netscape. I will still say that actually the use of Netscape is kind of waning at this point. There are some text mode browsers too called Lynx. So in the graphical area, Firefox is probably the most prevalent browser at this point, and this is very similar to has all the key features, just like either the Internet Explorer or the Chrome browser. So I think you will be using Mozilla Firefox more often on a Linux box. Then the Internet mail itself, that relies on the mail transfer agent to move the messages between hosts. We didn't see an example of this because this is pretty much under the hood transmission that happens. Though we learned about the mail delivery agent and the mail user agent, and then the mail delivery agent processes the mail as it gets delivered to the user's mailbox. We saw one example of that, and then the mail user agent that is used to read the mail and send messages. So the mail user agent reads local mail files, or it can also use this POP3 or the IMAP protocols to retrieve messages from a central server. The local messages essentially are previously people used to send between the two computers, and basically that is stored in the mail file that we all also already saw, the var spool./mail. The proc mail is used as a delivery agent. Basically, as the mail gets delivered, it provides like the message management, automatic filing, automatic replies, things like that. And these things you can construct it as a recipe, and then we also saw that there are two basically like two files that are used for configuration. There's a simple file and then also a local file. And finally, like the mail client itself, there are many popular ones. Elm is one, Elm and Pine. Basically, these are the, you can say like they are MUAs or the mail user agents. We saw an example of the text-based mail support and the ELM or Elm. This is essentially like the interface and essentially the commands are just like using a visual editor or VI. There are other mails also that are kind of popular, fetch mail, kmail, balsa. And one thing I will ask you is actually to use the man mail command to just see what happens when you invoke a mail, and then see how this the mail works, or what are the different commands, what are the different options available, and then are there any arguments. You can also think of that, and you can see whether there are any arguments for that. So this will pretty much conclude the overall lecture on the mail and the DNS. I hope this one was useful. Now we go into more distributed file system, where we talk about the whole file system structure in the Linux. We actually like looked at it briefly. We know that there are different files like /etc, /var, /dev, /root, all those different files systems. Now we will learn about how to do it between the networks, and what happens when we do that, and how do we maintain consistency, because there are some metrics that are really important to maintain that kind of a scenario. So let's start looking at the file systems. So we'll talk about the distributed file system in the context of Linux. So in this section we will be talking, we'll provide an introduction, then we will go into the file services architecture, and then we will take up two very popular case studies. One is the Sun NFS system, the network file system. This has been like analyzed and overanalyzed and underanalyzed, whatever you can think of the objectives, and we will always quote this one. And then the second one that we will look at is the Andrew file system, which is also a distributed network file system, which was initially started at CMU, or the Carnegie Mellon University, and then as a part of the Andrew project essentially. So we will learn about that, these two file systems as a part of this distributed file system, and just compare and contrast what is in each of them. So let's look at the file system. The file system is essentially it's originally developed for a centralized computer system or a desktop system. It was an operating system facility providing a convenient programming interface to disk storage. So you know that basically the memory itself. So we will go into the various hierarchies of memory, but there is a storage that you can think of in the software context where the programs are stored. I think like when we started looking at the shells, we learned about the difference between the programs and the processes. So at a glance, actually, like you can think of there's a system where programs are stored, and that needs to be brought out whenever they are queried, and then basically like that runs as a process. Like an instance of running program is a process that we saw. So now to get that program out, the file system is operating system's way to provide a user method to access these programs or things that are stored. So instead of like saying that okay, go to sector 12 on disk 4 to get me my program, you can say simply that go to /home/x/y, and that's where my program lives. So it's basically like so there's a lot of translation that goes on behind the scenes. But now the interesting challenge is like if this is the disk is the /home disk is not on your computer and it's residing somewhere else, how do you make sure that you can see that? On the other hand, you can also think of this as say if that disk itself is not available, what happens then? Do you see it? Do you don't see it? How the computers will react to it? So we'll learn about that. So a distributed file system supports sharing of information in the form of files and hardware resources. So there are distributed object systems like Corba and Java and the web. The picture has become much more complex. So what I mean is like again exactly the same thing. Basically now your disk no longer resides in your computer, it resides far away. Maybe you have connected through a network into that particular computer and you know how to access it. What should be the name of that? Can you name it as /home/x, same as another /home/x in your computer? So think of it this way. Now you saw like there are addresses, IP addresses, and there are translators between the IP addresses, and there are DNS resolvers. Similarly, you can think of now the files can be distributed, and every file needs to have an address or a unique name, because if you don't have the unique name, then you won't be able to access that, or there will be like name collisions. So how do you provide that unique name, and how do you manage the whole file system infrastructure? Those are the things that we will be worrying about. So before we start that, let's look at the types of storage systems. This is one of the key parts and one of the key things that we will go through. First of all, I want to introduce certain key concepts here. So look at in this table, look at all the column headers. So we have like sharing is one of the attributes that we will be describing on what the memory storage system should have. Then the persistence. What do you mean by persistence? So sharing, we know that actually whether the same thing can be shared between multiple resources, or is it just single resource? For example, a main memory in this case is just shared by just that one CPU. Today, if you know about any of the computing systems, there are gradations of this memory. All the way from the L0, L1 cache to L2 cache to specific L3 cache also, and then going to the main memory. This is especially true when we talk about like the multi-core systems, where a machine is not just formed by a single core, but there are multiple cores that are working, and each core can operate one or more threads of computing. So we can say like if you have a dual core machine, internally it can execute 4 programs simultaneously in the system. And so like some programs can share the memory, some programs may not. Even main memory can be shared between the 2 threads, whereas the caches cannot be shared between the threads, and each core can have its own cache, and which it divides it between like a couple of threads also. So again, sharing is one of the attributes of the memory. The second one is persistence. So what do we mean by persistence? Persistence is something that is the data that we write into a particular storage is always there. Whether it is always there or not depends on the persistence of the particular system, how much it is persistent. So for example, in main memory the data may not be persistent, because wherever we write, actually the data gets overwritten very quickly with something else. So usually like this is these memories are smaller and but very fast or having high bandwidth. We will also talk about that. Then there is a distributed cache or replicas basically. So when the cache is nothing but a buffer essentially. So if you want to serve a particular entity or serve a node like a CPU, then you need to have provided with the data whenever it needs it, not whenever the data is available. So there's a big difference between those two. If you only want to provide when the data is available, then probably like 99.1 or 99.9% the CPU will be just starved, because it won't be able to get to the data. So you want to provide it when it needs it as opposed to when the data is available. So a cache is a good means to provide that, because you can prefetch the data and keep it in the cache, and the CPU will only access the cache, whereas when the cache is getting emptied, it gets more data. So that cache, distributed cache and replicas, that's again determined. That's another determinant of the storage system. So in a storage system like main memory or even a simple file system, you may not have any distributed cache or replicas that is there. Then the fourth point is the consistency maintenance. Here actually like it's depends on how you maintain the consistency of data. So the high bandwidth or the memories that are very close to the computing system itself, they will have a consistency maintenance property as a 1 copy consistency. Here it's represented as 1, and so the example is RAM, that is what is quoted for main memory. But you can think of basically it only has only 1 copy. It doesn't store more than 1 copy, because you can think of this as like, because it's so close to that the computing device, the data is constantly getting updated. So you cannot keep more than 1 copy, because suddenly like other copy becomes stale. So it becomes stale very easy. So you don't want to have more than 1 copy. File system, again the same thing essentially. We will talk about the distributed file system and all those things. I also want to have add one more property to this one, which is bandwidth, which is not covered here. Again, so for the fast memories, essentially like, or the memories that are very close to the computing computing platform, we want them to have extremely high bandwidth, so that the CPU never starves for data. And there are ways of doing that, but one thing is to just use the semiconductor physics, which is use the speed up of RAM to make sure that those CPUs are served well. So let's look at and compare the various storage systems. Main memory, if you think of main memory as a storage, it has very strict one copy consistency, but other than that it doesn't have sharing, it doesn't have persistence, it doesn't have distributed cache or replicas. Now let's look at a standard file system in Unix, which is basically confined to that particular client. Again, that one does not allow sharing. It has persistence essentially, and it does not have any distributed caches or replicas. And then the consistency maintenance is, again, it uses a strict one copy consistency. Now let's look at the distributed file system. Distributed file system allows you to share, allows persistence of data, allows distributed cache or replicas, and it is also it manages consistency, which is again you don't need to have like multiple, a single copy for this. So it is kind of consistent, basically like slow changing, but at the same time any point of time you can read out that and read out the particular distributed file system storage and then get the same data back. So an example could be the Sun NFS, which we will study in detail now. The other one is the web, where again it has sharing, persistence. It also provides the distributed cache and or replicas, but it does not provide the consistency. So when you do something and then when you come back, it may not be consistent anymore. So a typical example will be a web server. And then there are other things, basically distributed shared memory, which is again the concept is sharing. So it allows you to share, but it does not provide persistence. It allows the distributed cache and replicas, and then but it also allows the consistency. Then there is something called remote objects, or RMI or ORB. The example could be like the score bar that we talked about earlier. This provides only sharing, no persistence, no distributed cache, and also like just one copy consistency. And then there's something called persistent object store. This provides the persistence essentially, and it also allows the sharing, but it does not allow distributed cache or replicas. And then the consistency maintenance is also like it's only one copy consistency. Then we have peer-to-peer storage systems. They provide all of them essentially, and an example could be the Ocean Store. So now let's look at the module structure of the non-distributed file system. So this one it's basically like since it's a non-networked system, it has a directory module. This basically like relates the file names to the file IDs. So it's kind of the same as a DNS resolver that we can think of. The file module itself relates the file IDs to particular files. The directory module actually can also have the directory names associated with it. Here basically like the file module relates the file IDs to the particular files. And then the access control module, this checks for the permission of the operation that is requested. We also saw this in the beginning of lecture 2, where we could assign the files with various properties or permissions, like read, write, execute. So the file access module checks for that. The block module accesses and allocates the disk block. So as I mentioned, basically like you need to know like which sector or which block where the program is residing. So that's all taken care by the block module. And then the device module does the disk I/O and the buffering. So it basically communicates to the disk and then stores the various files in that. So this is a very simple single user file system essentially. And then the file systems essentially is that's where we organize, store, retrieve, and some naming, and then as well as sharing and protection of various files. So the files can contain data and attributes. So let's look at some of the attributes of the record structure here. So the things that you want to store are the file length, then it was created at creation timestamp, then it was last read read timestamp, and then when was it updated with some data, which is the write timestamp, and then any other attributes you can provide that, and then the attributes timestamp also is provided, and then finally a reference count is given, and then there is also like encoding in form of the owner and the file type, and then who or who cannot access the file, and this is called the access control list, and that's also provided so that it goes with the software, and essentially like it goes with the file, and if the user is not authorized, then it won't like let you proceed. It will not you won't be able to read that file. So in the next figure that we will see basically like all the operations on the files that are available to applications in the Unix system. So when we say open and the name and the mode, essentially like so that opens an existing file with a or open the file with a given name essentially. And then when we say like file does equal to create name mode, this is actually creating a new file essentially. So the file descriptor is in this file DES essentially. DES stands for the descriptor, which is kind of just a number that it returns. It's typically a pointer to the head of heap or section of memory where that particular file is getting stored. File called the name. Then you have a status that you can set, and usually like when you do a close and then you can give the file handle. So I'm going to refer this as file handle from now onwards, the file descriptor. Essentially it's like a pointer to the head of the file, so that we know that is the start of the file, and then we can even read that the fields that we mentioned in the previous slide, which is these things, the file length, creation timestamp, etc., etc. So the file that gives a pointer to that particular head of that particular table. We can give the count. So here, like we just store the count in a variable called count. So the command is again read file does buffer n. So essentially the buffer stores the n bytes of the read, n bytes of the file DES, and it stores it essentially like the buffer, and then that's what is in the count. So the count displays the number of bytes essentially on the server. You can also do write file does buffer followed by n. They both deliver the number of bytes actually transferred between the advanced the they both deliver the number of bits that are actually transferred, and it also advances the read pointer to the next location. And then the other command is the lseek command. Lseek file does offset whens. Essentially, like it takes the read write pointer to that offset related to an absolute number, and that is given by this whens variable. And then the other one is unlink name. This removes the file name from the directory structure. If the file has no other names, then the file is deleted. Yeah. Then we saw a soft link earlier. This is the hard link of the link name1 name2. This adds a new name called name2 to name1. So again, it just provides another pointer to the same header information where the file name2 or name1 asset. Then the other command is the status command, which is stat or just the stat, and then essentially that gives like it gets all the file attributes of the file name and then stores it into buffer. So we studied about a few things essentially, like we will talk about this briefly, and then we will stop at this point, and then the next time onwards we will expand this. First of all, give you all the definitions of all these different terms, and then we will move forward. So just wanted to give you this, basically the distributed file system requirements. Essentially it requires transparency, concurrency, replication, heterogeneity, fault tolerance, consistency, which is different from the transparency and other things, security, and efficiency. So we will talk about what each term means in the context of a distributed file system, and then also how to compare different file systems in the next chapter. Thanks.